Well, hello, my name is Jessica Smarsch. I am a designer, and for the past 3 years, I've been working in the area of stroke care. My master's study at the Design Academy Eindhoven was in social design, and I'm very motivated by the effects that design can have on health and well-being. Today, I would like to look at and frame wearable technologies as a transition from hard to soft, not only in terms of the materials that are used, but also as an approach and a way of designing the user experience. Speaking of user experience, I want to start off by showing these images of the medical brace that my neighbor was fitted for in 2006 when she was diagnosed with arthritis, which caused severe discomfort in her hand. The silver brace prevented her from moving her hand in a way that would trigger a painful pinching sensation. And it worked. And not only did it work, but you can also believe that she felt good wearing it. It was lightweight and comfortable, and she wore it every day. Eventually, after some years, the brace got bent out of shape. In 2018, she went back to the doctor to get fitted for a new brace and found out that the company who designed it was no longer local, and they sent her to a different company for the fitting. This was the new brace she was given. You might notice a small difference from the previous design. The brace was difficult to put on, uncomfortable, unattractive, and she wore it one time. Besides the physical feeling of it, she felt like it shouted out to the world that there was something wrong with her. So often in healthcare, we see products that are designed to solve a physical problem, and when used, the products work. But products can't solve problems when people refuse to wear them. And on the other hand, when people are forced to use products which lack emotional design consideration, the person is reminded of their problem instead of their health and well-being. The World Health Organization defines health as a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. Today, I will introduce you to my own work, but also show a couple examples of designers who are working with wearable technologies and taking what I am calling the soft approach, embracing functionality, but also aesthetics, emotions, dignity, and the sense of personal identity that is always tied with anything that we wear. The first project I'd like to show is from Julia Tomasello and is called Alma. It is an underwear with an integrated sensor that helps women track the pH of their vaginal discharge so they can know if what they are experiencing is an infection. On the left, you see sensor strips developed in a PET flexible plastic film. And on the right, you see what they are developing now with collaborators at Fraunhofer in Berlin, a textile-based sensor. And the first tests to see if a silver-coated textile can be used as a pH sensor have shown positive results. Obviously, for such an intimate area of the body, being able to use soft materials makes a big impact on how the wearer experiences the product. Another project that I like is called IV Walk from Elisa Reis. It's not a wearable technology in the sense that it integrates electronics, but it is a very good example of moving from hard to soft in terms of materials and experience. The wearable replaces the typical metal intravenous poles that patients are attached to in the hospital setting. The design integrates the medical fluid sac inside of the wearable and allows patients to freely move about and even access the outdoors, which helps to foster a sense of health and well-being. The design lets the wearer feel comfortable and considered, both physically and aesthetically. And I will show two more examples, both from Pauline van Dongen, who has been working in the area of wearable technologies for the past many years. The first project I would like to show is called Isho, and it incorporates conductive yarns and a microcontroller. When the fibers register touch, an integrated component delivers a gentle stroke on the upper back. A previous iteration had a more sporty design and was developed to help people correct poor posture, but the Isho design was developed to simply encourage the wearer to be present in the moment through body awareness. And finally, also from Van Dongen, is the Radius backpack, which uses circular knitting to knit the body of the bag in one piece. The technology is in the strap of the backpack, which integrates a special yarn developed by Japanese company Svalar. This yarn is bonded with very small spherical solar beads, which when woven, create a flexible solar panel. Unlike typical solar cell films, this is truly a textile. So these are just a few examples of designers who are working with wearable technologies, and I think it shows how sensitivity to design can make a big impact on how the user experiences the product. Particularly with electronics, which are typically using plastics and metals, when we are integrating technology into clothing, it's important to keep in mind how these products feel on the body and also the power they have to impact how the wearer feels about themselves. So I'd like to transition now to the focus of my own work. And for the last 3 years, I've been working in the domain of arm-hand rehabilitation for people affected by stroke. I arrived at this focus when I met a neuroscientist named Raymond Vanet, who saw how my previous work was pairing rhythmic movement with audio and visual feedback. This is the final project that I developed during my master's at Design Academy Eindhoven in 2015. It is a system that allows people to design patterns for textiles using a custom software. It also used the Myo bracelet, which was a commercially available product that had 8 EMG sensors for collecting muscle activity and an IMU unit for capturing movement in space. The interesting part for stroke patients is not about creating textiles. As a stroke rehabilitation system, we focused on the process of delivering feedback on movements, which can help patients to exercise correctly. This system also turns the stroke patient into a creator as they generate artwork with their bodies. In that sense, it has the power to change the perspective of what it means to recover from a stroke. As we started to develop this concept, I also wanted to rethink the wearable to collect data from more areas of the body and also integrate it into a comfortable design. Before going into detail about the developments, I want to show the Smart Glove from a company called NeoFect. The Smart Glove is also a wearable technology for stroke patients, and it delivers feedback using avatars to simulate the movements the patient makes. This is a good product, and I think as a design, it looks really cool. But when I see it on the body, it reminds me a lot of the blue brace that we saw from the beginning of the presentation. So the challenge that I've given myself is to see if we can find an alternative design and solution that patients can wear to feel natural, confident, and comfortable. Let me take you through some of the developments and let you see what that process has looked like. The mission with the development of the Constructing Connectivity system is to use beauty and creativity to sensitively engage stroke patients in a multisensory healing process. The plate you see represents one of the core values, which is focusing on the beauty of the repair process. Kintsugi is the method of repairing broken ceramics with silver or gold, making something which has broken more beautiful than it was before. In addition to the emotional metaphors, Kintsugi teaches us about sustainability. There are different ways of regenerating a product, including recycling and reuse, but repairing is the most sustainable way to retain value and prolong a product's lifespan. Here we can see the second iteration of the system from April 2019, where a stroke patient wears the Connextile sensor shirt in her home. In the sleeves, you can see sensors that measure her muscles and movement. She performs practical activities and receives visual feedback and performance results as seen in the app on the right side of the image. To understand the system better, I'd like to show a short film. we can see in the film that we aim to create a beautiful process for the patient. We also see the concept for the sleeve exchange, which encourages the patients to embrace the growth and change they experience. Also, by having the patients return the technical sleeves, we can reuse the electronics and recycle materials where possible. Following this stage of the project, I was chosen as one of 10 artists in Europe to work together with scientists through a grant called Reframe. There are several different technology companies in the consortium, and my main partner has been Fraunhofer IZM in Berlin. Fraunhofer has developed a technique they call text PCBs, which laminates conductive fabric between thermoplastic material. This technique has the potential to be applied to a wide range of applications, and I have been working with them to create designs suitable for EMG measurements. This has proven to be a good method for collecting data and has manufacturing potential. On the left, you can see new concepts for minimizing the design of the wearable garment, which would include sensors all along the wrists, arms, and shoulders. At the top left, you can see the armbands that we make for testing the products, here shown inside out. And on the right, you can see some of the material experiments that I am making right now with the knitwear lab here in the Netherlands. We are testing ways to knit in specific materials where the sensors are placed, and we are also experimenting with combining different yarns and knit structures to combine lightness and breathability with the necessary compression needed for EMG measurements. The goal is to create something that works, but that is also elegant and even revealing some of the beautiful aspects of the technology. Speaking about compression, when trying to find technical solutions, I have tried to think beyond easy solutions that may work, but may also end up feeling medical, uncomfortable, or unattractive. For example, in one experiment, I was reminded of the finger trap toy we see at the bottom left, which becomes looser when pushed together and tighter when pulled apart. I made one myself and then transferred the technique to fabric on a larger scale to see how such a structure could be created. From there, I reduced the technique to the yarn level and created tubular structures that could become tighter in specific areas when pulled. This would allow a garment to go on loose but become tighter for brief periods during data collection. Another concept for creating compression is to use a 3D printed design that can snap together and change the shape of the garment, as seen on the right. The sample seen at the top are the first 3D print trials of the snap concept. I like that this technique has the potential to create an interesting aesthetic by how the pattern is printed on the textile, but it also has a function and can even allow people to custom shape their clothing, which can be useful for sizing, but also for creating personal style. Another company in the Reframe consortium is Stratasys, one of the largest manufacturers of 3D printers. And they have developed incredible techniques for printing on fabric, including these polyjet examples seen at the bottom, which use a lenticular lens to bounce light and change color through movement. In the stroke garment, we use a small module from I2M to collect and process the data, and this needs to be attached to the garment. This snap technique that we have developed, combined with the printing techniques of Stratasys, have the potential to turn a functional element, such as a processing module, into a beautiful accent of the design. Over the summer months, we will continue to work together to bring these mini ideas into one garment. We are looking at the male and female body and studying how we can map the pattern construction of the garment to the muscles of the body. We are also trialing many combinations of fibers and structures to find material combinations that are comfortable and functional. And through this process, we are looking for elegant solutions to fit and flatter all body types. I hope you've enjoyed my perspective on wearable technologies, particularly in the domain of health and well-being. There are many ways that we can use design to soften the experience for users. I am excited that wearables give the opportunity for textiles to bring sensitivity, tactility, and emotion to the world of technology. Thank you.